This lesson will continue on with Big Idea 1 Standard 1. The topics for today are both ions and isotopes. So first, let's start with ions. An ion is an atom that has gained or lost one or more electrons and has a charge. So when you're doing problems, you have to be very careful about what the question is asking. If it tells you it is an atom, atoms are neutral, protons equal electrons. Ions have a charge. So anything that has a charge, like +1 or -3, we do not call an atom, we call it an ion. We have different names based on whether it's positive or negatively charged. So a cation is an ion with a positive charge. And the way that we get a positive charge is by losing electrons. So a cation is an atom that lost electrons. The atom loses electrons. So let's talk about that a little more. How do you lose electrons and become positive? So remember, electrons are negatively charged. So if you lose an electron, it's like subtracting a negative in math, your answer becomes positive. So if an atom loses an electron, it has less negative charges, it becomes more positively charged. Anion is an ion with a negative charge. Cations are positively charged, anions are negatively charged. The way that an atom becomes an anion is that atom gains electrons. So again, electrons are negative. If you have an atom that is neutral and it gains electrons, you're adding more negative charges, it's going to be overall negatively charged. Well, how do you remember which one is which? Remember that cations are positive because cats have paws. Cations are positive. It's just a silly way to help you remember which one is which. So what we're going to do today is you are going to have to determine the charge. So a few things to think about when you need to determine the charge of an ion. It depends on the two subatomic particles that have charge. Neutrons are neutral, so they don't affect the charge. Charge is the difference between protons and electrons. If it is an anion, you should have more electrons than protons. That should make sense. Anions are negatively charged. In order to have a negative charge, you need more negatives than positives. If it is a cation, you should have more protons than electrons. So we're going to look at questions a few different ways. First, let's say you were told an ion has 17 protons and 18 electrons. and you need to determine the charge and if electrons were gained or lost. So first, let's look at the difference between our protons and electrons. I have 17 protons, and protons are positive. I have 18 electrons, and electrons are negative. Well, that means my charge is going to be a -1. I have one more negative than positive. Next, were electrons gained or lost? Two ways you can figure this out. You can memorize it, which I don't recommend. If it is a negatively charged ion, like -1, the atom gains electrons. The other way we could do this is just think about this logically. As an ion, it has 17 protons and 18 electrons. If it were an atom, remember the number of protons never changes. If it were an atom, the number of protons would be equal to the number of electrons. So in order for this to be an atom, there would need to be 17 protons and 17 electrons. Well, now we can easily see that in order to get that -1 charge, we needed to gain 1 electron. Let's try another. An ion has 12 protons and 10 electrons. Determine the charge and if electrons were gained or lost. So again, to determine charge, we want to look at the difference between protons and electrons. 12 protons, 10 electrons, my difference is 2. And I have 2 more protons, 2 more positives, so my charge should be +2. 12 protons gives me 12 positives. 10 electrons gives me 10 negatives. So my net charge is +2. If I have a cation, a positively charged ion, that means it had to lose electrons. Electrons were lost. And again, we can think about this in terms of what we know about atoms. If this were an atom, the number of protons, we said never, ever, ever changes. I would still have 12 protons. But if it were an atom, protons must equal electrons. So as an atom, this is magnesium. Magnesium has 12 protons and 12 electrons. As an ion, it has only 10 electrons. That means it had to lose 2 electrons. If you lose 2 electrons, it's like subtracting a -2. It becomes +2. Let's say you were given a table. All right, first one. I have 10 electrons, and the charge is -3. So since it's negative, I know there are more electrons. If it is an anion, which means it's negative, there are more electrons than protons. And since the charge is -3, it means there are 3 more electrons. And again, you can always double check with some math. If I have 7 protons and protons are positive, that's a +7. I have 10 electrons, and electrons are negative. That's a negative 10. If I have 7 positives and 10 negatives, it gets me to that net charge of minus 3. I have 1 more proton, and protons are positive. Again, we could do the math. 11 protons, 11 positives, 10 electrons, 10 negatives. My net charge would be a plus 1. Last one. I have 8 protons. My charge is negative 2. That means I have 2 more negatives. So I would have 10 electrons. Let's check our work. 8 protons, meaning I have 8 positives. 10 electrons, that gives me 10 negatives. 8 positives, 10 negatives, gets me to that net charge of negative 2. Last example for ions. Let's get back to that notation. This is what it would look like if it were an atom. So atoms don't have a charge. If it were an ion, the charge would go in the upper right corner. All right, so let's go through all this again. The bottom number is the atomic number. The atomic number is equal to the number of protons. The atomic number is 16, so there are 16 protons. The top left number is the mass number. Mass number is protons plus neutrons. So if I take my mass number of 32 and I subtract out 16 protons, I would get 16 neutrons. Up here is the charge. My charge is negative 2. That means I have 2 more negatives. If this were an atom, I would have 16 protons and 16 electrons. My charge would be 0. In order to have a charge of negative 2, you need 2 more negatives, and electrons are negative. 16 protons means I have 16 positives. 18 electrons means I have 18 negatives. 16 positives, 18 negatives gets me to that net charge of negative 2. Last thing for today is I want to introduce isotopes. We're going to talk more about isotopes later this unit, so I just want to introduce them for today. Isotopes are 2 or more atoms of the same element. If they're the same element, it means they have the same atomic number. But different mass numbers. So let's break that down a little more. Elements with the same atomic number. That means that isotopes have the same number of protons. But the mass number is different. So if isotopes have the same number of protons but a different mass number, that must mean they have a different number of neutrons. So let's look at an example of isotopes. Carbon 12 and carbon 14. These are isotopes. 2 or more atoms of the same element. They're both carbon. Since they're both carbon, they have the same atomic number. Carbon has an atomic number of 6. The atomic number is equal to the number of protons. So both carbon-12 and carbon-14 have 6 protons. But they have a different mass number. My first isotope has a mass of 12, my second isotope has a mass of 14. If I take my mass of 12, subtract out 6 protons, carbon-12 has 6 neutrons. If I take my mass of 14, subtract out my 6 protons, carbon-14 has 8 neutrons. So again, carbon-12 and carbon-14 are examples of isotopes. We see that they have the same atomic number, so they have the same number of protons. They have different mass numbers, 12 and 14, which means they also have a different number of neutrons.